Hello everyone, welcome back to my channel. In today's video I am going to explain you about recursion concept and also the internal process that will be happening in the recursion, and I will also explain you about the tree recursion. Without any further delay, let's get into the video. By the way, I am Sivathmika Chavali. If you are new to this channel, please make sure to subscribe to my channel and hit the bell icon. So let's get into the video. Recursion is nothing but a process in which a function calling the itself again and again. Suppose if I take the function called f, and here in this function I am giving the parameter as int a. Previously, like if we initialize the a value as 1 now, and I am just printing this a value here, and again I am incrementing this a value by 1. Now here I am calling this function again, right? Suppose this is one sample program in order to explain you the recursion. See, at first it will execute, this line will be executed, right? And here the a value is 1, right? As we initialize the a value as 1. Now next, this line will be executed, and in the output, this is the output. In the output it will print a value. The a value is 1, so it will print a. And next this line will be executed. Here the a value will be incremented to 1. So a equal to a plus 1, that is a equal to 1 plus 1. So now the a value will be 2. Now here when it comes to this line, this function is calling this function. It's like a repetitive, right? Now again this will go back to this first line, and when this line is executing, it will take a value as 2, because here the a value changes to 2. So now it will take 2 value, and again this line will be executed. Now it will print a value. As a value is 2, 2 will be printed in the output console. Now again it will come to this line, a equal to a plus 1. 2 plus 1 is 3. Now a value will be 3. Now again when it reaches to here, it will again call this function. Again it will go back to the main function, and now the a value will be 3. Now this line will go to this line, and it will print the 3 in the output, and again a value will be incremented to 4 now, and again it will call. It's like we will call again and it will come back, and it will call again, it will come back. It's like a repetitive. So this process is called recursion. It's like a recursive way. Now here, as there is no stopping condition here, you can see it will call and it will again execute. It will call, it will again execute. Here there is no stopping condition. It will print all the values 4, 5, 6, 7, 8, all the values like this. It will continue to execute to print the value of a. Then how can we stop this program? If we does not stop this program, it will lead to stack overflow. This is like an exception. So in order to stop calling the function itself, we need to mention base condition into our program, right? We need to mention base condition. Base condition is nothing but it's like a stopping the recursion process. Suppose if so this is the recursive process, right? Now in order to stop this process, we have to apply one base condition, like anything. Like if a is equal to 5, you just stop it here, right? So this is the base condition. This is the base condition we need to add into this program in order to stop the recursion, right? And you can even also add anything into a program, into your program. The base condition depends on your program. Here I am giving 5 as my stop condition. Like whenever the a value becomes 5, you need to stop, and you just exit from the program. Like I am telling the compiler to exit from this program, right? So let's decode this one. So previously a is equal to 1, right? 1, and it will print, it will check whether the a is equal to 1 or not. Is a is equal to 1? No. A is equal to 5? No. It's a is equal to 1. So this if statement will not execute, it directly print 1 and again it will increment to 2, a value 2, and again this function calls again, and again it will check whether a is equal to 5 or not. As a is equal to 2, if condition, again it will not execute, it will print 2, and again it will increment to 3, a value is 3 now, and again the function calls, and it keeps on repetitive. Now if a is equal to 5, a is 3 but it is not 5, so again if condition will not execute, it will print 3 and a value becomes 4, and again function will be called here. Now 4 is equal to 5 but a is equal to 4, right? So if condition will not execute again, so it will print 4 and again a value becomes 5. Now again function calls, a equal to 5. Yes, here a value is actually 5, and here you can see the condition, it is true. So now the if statement will execute and it will return, it will exit from this program. So this is what, now this is the output. So this is how the recursion happens in these programs. Now what happens in this tree recursion? So tree recursion also follows the similar way. Suppose if we take some binary tree, let's take a binary tree as 3, 4, 9. This is the binary tree, right? Now how the recursion happens in this binary tree? Let's take a function called tree, and it will holds root node, right? It holds root node. Now here, if I call this function again and again, now here in the place of keeping I am giving like root dot left, I am calling root dot left. This is root dot left, and that's it. This is my program. If suppose this is my program, at first it has parameter called root. Actually root is 3, right? The pointer points to the root node. So root in root it is 3. So that means 3 is there here. Now this line will be executed. Tree equal to root dot left. Root dot left means this is left subtree, right? And this is right subtree. As you can see, from the root go to left side. Okay, this is the root, right? Now this root left side is 4, right? Now the pointer points to 4, right? In the place of root, in the place of 3, it points to 4 now. Now again the function will calls this again and again. Here you can see again this will execute. Again root dot left. Previously the pointer points to 4 node. Now it will check root dot left. So for 4, left side is 6th node, right? 6 number node. Again this pointer moves to this node, right? Now again the function will call itself, it will execute this line. Again tree equal to root dot left. Here you can see it is pointing to 6th node, right? When it comes to root dot left, here you can see there are no nodes. Like root 6 is a leaf node. It is a leaf node. It does not contain any left children or else right children. That means here you can see it points to null node, right? As it does not contain anything, this node will point. Now the pointer points to null node. Now again this function will be called again and it will execute. Now here you can see tree equal to root dot left, but our root contains null. That means it is empty. As it will keep on executing, here you can see as this is null node, it will throw null pointer exception, right? Null pointer exception. So in order to stop this null pointer exception, we have to include base condition. How can we include? Let's write again 3, 4. Now 3. Now again. Now we need to include the base condition. Like what? How can we include? If root is equal to null, just exit from the program, return, right? And we are calling again we are calling the function root dot left, right? Now let's decode this one. So here the tree, it will contains the root, the pointer points to root. Now this, it will check whether root is equal to null or not. Root is 3, right? This is, let's write root is equal to 3, and here you are checking whether root is equal to null or not. As root is not equal to null, this if condition will not execute. So pointer so this will go to this line. Now tree dot left, root again this function will call again, and here root dot left, it will change the pointer to root dot left 4. Now root contains 4 node, right? Now again it will check whether the root is null or not. Root contains 4, so it is not null. This will not execute, and it will execute this line root dot left. Root dot left means for 4, left node is 6, right? So it will, the pointer change to 6. Again this function will call, and again now this root contains 6, right? Now it will check whether the root is null or not. As root contains 6, it is not null, so it will not execute this if statement, and it will go to this statement, and again root dot left. Root dot left is null, right? Root dot left, it does not contain anything, so root dot left, it will points to null. So this is root contains null node. Let's write null. Now again it will go back to this, it will call the function again, and if statement will be executed, and here it will check whether root is null or not. Yes, root is null here, so it will stop and it will return. It will return to main program. So this is how recursion happens in the trees. In the similar manner, if you keep root dot right here in the place of root dot left, if you keep root dot right, function will happen, but in this direction. First root will be 3, and then it will goes to 5, and then it will goes to 9. In this way these elements will be executed. In like how the root dot left, these elements are executed, in the same way right side will be executed. If suppose if I give in the place of root dot left and root dot right, if I keep all these, if I keep both root dot left and root dot right, means see how this will work. Let's see. Now at first root will be 3, right? So root contains 3. Now it will check whether root is null or not. So you can see, as root contains 3, it will not this if statement will not execute, and it will directly goes to this statement. So here you can see root dot left. Now the pointer points to 3, right? It's saying that root dot left. So roots, whatever that is present in the root, you should go to left side, right? So now the pointer changes to 4. Now the root contains 4 as its root, right? Root contains 4. Again, as this line will be, as this line is executed, it will call this function again, right? Now again it will check whether the root is null or not. As root contains 4, it is not null, so it will not execute this statement. Again it will go to this statement, and here you can see root dot left. Again this pointer moves to root dot left, that is 6. Now root contains 6 node, right? Again, as the function is called, as this function again it calls again, so again it will check whether this root is null or not. So root is not null as it contains 6. This if statement will not execute, again it will come to this statement and it will execute root dot left. Root dot left is actually null, so it will, root contains now null node, right? Again this will go back to this function again, and this if statement will be executed, and here you can see it will check root is null or not. Yes, the root is null now, so it will return. So it will return to this statement, and now this freshly this root dot write will be executed, right? So now now this line will be executed. Root dot write is null. Again, as it is null, again it will go back to the function root dot write. It will check whether root is equal to null or not. Yes, root is null. Again it will return, and it will again come back to this statement, because you can see in this fourth node this is root dot left, right? And here you can see root dot right is also there, right? So it has to execute this right also. Now again this will call, now this will again call this one, and now the root contains 4, node 4, and here it will check whether it is null or not. No, it is not null. So as this root dot left is already completed, it will go to root dot right, and now the pointer points to 7th node, right? Now here in the root you can see 7th node. Again the root dot right contains 7th node. Again this function will call, here you can see root is equal to null. It will check whether the root is null. It's null? No, it's a 7, right? So this if statement will not execute. It will again come to this statement, root dot left. As root is 7, right? Is left is present for 7? No. Even right is also not present, right? So when this statement is executed, root dot left is null, right? So root dot left is null. It will again go back this statement, and it will check whether root is null or not. Yes, root is null. Root is null. So it will return, and this statement, from this it will go to this statement, and it will check root dot right. Root dot right is also null, right? So it will check and it will return. So it will return nothing, like it's a void, right? So it will return nothing, and from this it will go to this root. So again now it will reach to main root, right? It's like a backtracking process. Recursion follows backtracking process. Here from this you can see entire left subtree is completed, right? Now the right part is there. That means entire root dot left, I mean for this left side is completed, and in the subtree right side is also completed, right? Now for this main root, right side is balanced. Now we are checking right side. Root dot left is completed. This statement is completed for root 3. Now this statement has to be executed. Root dot right. Now the pointer points to 5. That means in root it contains 5th node. Now contain 5th node. It will check root dot right, and again it goes to this, it function will call this function again, and it will check whether root is null or not. No, root contains 5, it is not null. So if statement will not execute, and it will come to this statement root dot left. Root dot left is 8, so the pointer will goes to 8. Now in the root you will have 8. See here in this root, left side is only left side is completed. That means this one is only executed, this one is balanced. At first we are checking left side, okay? Now here, now the root contains 8. Again this will go back to this main function, and it will check whether root is null or not. So if statement will not execute, and again it will come to this root dot left statement, and it will check whether root dot left is null. Yes, here the root dot left is null, right? 8 does not has any left child or right child, right? So it is a leaf node. So root dot left is null to 8. So it will return. And for the 8th node, root dot right will be executed. Root dot right is null. So again it will return. And it will come back to 5, right? It will come back to 5th node. It's like a backtracking. Now in the 5th node, left side is completed completely, right? Now the root dot right is remaining. So root dot right, it will come to this 9th node. Now the root contains 9, the root contains 9, and again root dot right, again this will call this function again, and it will check whether root is null or not. Yeah, no, root is not null, right? So again this root dot left will call. For 9th node, root dot left is null, so it will return, and the root dot right is also null, it will return, so it will return nothing. And for 5th node, root dot left is completed and root dot right is completed, it will return and it will come back to original position, that is 3. This is how the recursion happens in tree. Okay, I hope you get this recursion concept. And yeah, that's all for today's video. Thank you for watching, and if you have any doubts or else if I made any mistakes, just feel free to comment on this video. Thank you for watching.